Hey guys, what's up people? Welcome to the session. How are you guys doing? We are back with the one shot series for ninth grade for force and laws of motion. Today we'll be doing everything that is pertaining to this chapter, from the revision to the questions that you can possibly expect from this chapter. Every single detail we'll be going through, every single important topics. So once again, welcome. My name is Anoop and this is the one shot series of force and laws of motion. And I'm aware that a lot of your exams are already done, your final exams are already done. Relax yourself, guys. You guys deserve a break, so take that break. And all the best for your 10th grade as well. Start your preparations right away. Get to know what are the topics that is going on around you, so that you get a better idea of what's happening and what you can expect in your 10th grade as well. All the very best, guys. With that said, let us begin the one shot series. All right, so yes, people, first thing what I'm going to do is I'm going to show you the mind map of this chapter. What and all are the important concepts that you must be aware of? I'll show you that. Then we'll go to each and every topic in depth. We'll understand every single topic, solve some questions in between, and also have a lot of fun as well, right? So let's begin, people. So these are the topics that we have in force and laws of motion: balanced and unbalanced force, first law of motion, inertia and inertia, momentum, and second law of motion, and third law of motion and conservation of momentum. So these are the three topics that we have in store for you guys. So without wasting any more time, this is our mind map. So the first thing you have to understand is this, guys. Force is nothing but a push or a pull, and you can have different types of forces. You have muscular force, which is basically you use your muscles to push or to pull something towards you, a magnetic force, gravitational force, electrostatic force, and then you have frictional force as well, which basically acts in the opposite direction. Then you have momentum. Momentum is nothing but the quantity of motion that a body possesses. That is what is called as momentum. So you have something called as the law of conservation of momentum. It states that the momentum of a body before collision will be equal to the momentum of the body after collision. In other words, the total momentum inside a system is always conserved as long as there is no external force acting on it. And the formula is goes so forth that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, where m1 is the mass of the first body, u1 is the velocity of the initial velocity of the first body, and m2 is the mass of the second body, and u2 is the initial velocity of the second body, and v1 is the initial final velocity of the first body, and v2 is the final velocity of the second body. So this is your law of conservation of momentum. Moving on, we also have the first, second, as well as the third law of motion. Newton's third law of motion, obviously. The first law of motion states that a body continues to be in the state of rest or in the state of motion unless and until an external force is applied on it. And this is also known as inertia. That is, the property of the body is what is known as inertia. The property of the body to remain, or the property of the tendency of the body to remain in the state of rest or in the state of motion is what is called as inertia. So a body with greater mass has greater inertia or higher inertia, and a body which has less mass has lesser inertia as well. Second law of motion is something that is related to momentum again. So second law of motion states that the force applied on a body is equal to the product of mass times its acceleration. So F is equal to m into a is the formula. A is nothing but v minus u by t, so you can substitute that in place of a as well. Third law of motion, this is probably the most easiest one. For every action, there's equal and opposite reaction. So for everything that you do, so if you apply a force on a body, so there's an equal and opposite equal force. There's a force acting, in the opposite direction, which is equal in magnitude but opposite in direction. That is what is your third law of motion. And then you have the units and dimensions, that is mass, weight, and momentum. Mass is nothing but the amount of matter which is measured in terms of kg, and you also have grams grams is one of them. So yes, if you talk about the conversion, 1 kg is equal to 1000 grams. If you talk about weight, weight is nothing but the force by which the force acting on a body because of the gravitational pull, or the force by which Earth is pulling it towards the center, is what is called as a weight. And the formula is weight is equal to mass times acceleration due to gravity. So W is equal to m into a is the formula for that, and the unit is kg meter per second square. And if you talk about the conversion, 1 kg meter per second square is equal to 10 to the power of 5 grams centimeter per second square. Why is that so? Because 1 kg is equal to 1000 grams and 1 centimeter is equal to 100 centimeters. So you get a 10 to the power 5 grams centimeter per second square. Then your momentum. Momentum, as I already told you, is nothing but the quantity of motion present in inside the body is what is called as momentum. It's the formula is nothing but it's represented as P. So P is equal to m into V is the formula, where P is nothing but momentum, m is the mass, V is the velocity. So the formula, the unit is kg meter per second, and conversion again is 1 kg meter per second. If you want to convert it, it's 10 to the power 5 grams centimeter per second. That's it, guys. This is the entire chapter. Now I'm going to explain each and everything one at a time. So to start with motions, guys, so if you talk about force again, to start with force again, force is nothing but the push or pull experienced by a body. So you have different types of forces. You have muscular force, magnetic, gravitational, electrostatic, and frictional. Muscular force is nothing but the push or pull that is exerted when by using your muscles. Basically, pushing something or pulling something towards yourself using your muscles is your muscular force. It's basically a contact force. Magnetic force is nothing but that like poles attract, repel, and unlike poles attract. Unlike poles attract. So that force between two magnetic material two magnets is what is called as the magnetic force. So that is again as a non-contact force. Gravitational force again as a non-contact force. It's nothing but the force by which Earth pulls anything towards the center is your gravitational force. Electrostatic force is nothing but when you basically the charge possessed by a body. So when you rub a body, it gets charged or it possesses some charge. Again, like charges repel, unlike charges attract. That is what is your electrostatic force. Examples, one of the examples that is nothing but thunder and lightning. Thunder and lightning is basically an example of electrostatic force. And frictional force is nothing but the force that acts in the opposite direction. So these are the types of force. Now I have I know that I'm talking a little too fast, so I'll slow it down. I'll just because these are concepts that you've already studied. I do not think that we need to spend a lot of time on this because you've already studied these concepts. So that is why I'm going a little too fast, just to brush up your concepts, but at the same time not to make it a little longer. I want to keep it as short as possible. So what is force? Once again, a push or pull experienced by a body or upon an object is what is called as force. So force has both magnitude as well as direction, and because it has both magnitude and direction, it is a vector quantity, not a scalar quantity. Now there are two types of forces. You have balanced and unbalanced force. Let's say there's a box, all right, and there are two people pulling from either sides, and they're applying the same amount of force. Let's say that both of them are applying, let's say, 10 Newton force. Now, if you see that the net force acting, because they're both in the opposite direction, it'll get subtracted, right? It'll get subtracted because they have because force is both magnitude and as well as direction. So when you consider the direction as well, because the magnitude is the same, because they're in the opposite direction, it's going to be negative. One is going to be positive, the other is going to be negative. So generally we take anything towards the right as positive and towards the left as negative. So if that is the case, what happens? The net force or the total force acting on that body is going to be zero. So when the net force acting on the body is zero, that is what is said as balanced force. Because in that case, the body would neither, if it is in the state of rest, it will continue to be in the state of rest. If it is in the state of motion, if it's already in motion, and if the net force acting on it is zero, it will continue to move in that same, same velocity or same uniform velocity itself. Whereas when there are, for example, in this case, there are two people applying, let's say that all of them are applying the same magnitude of force, all right? So this person is applying 10 Newton force, this person is also applying 10 Newton force, and this person is also applying 10 Newton force. But if you look at it carefully, on the left hand side, you have two people pulling it. So the total force on this side is 20 Newton and on this side is 10 Newton, which is 20 is definitely greater than 10. So that means the net force acting on it will be 10 Newton. So if the net force acting on the body is not zero, and when you calculate it, that is what is called as an unbalanced force. And in an unbalanced force, you can see that there will be some sort of motion, whichever is the direction of the force, where whichever side the magnitude of force is greater, towards that direction, you will be able to see some displacement as well. So when the net force in the body acting on the body is not zero or is not equal to zero, that is what is known as unbalanced force. Alright guys, so now that you've understood all of these concepts, let's quickly do some questions as well. Here's the first question. Find the value of x if system is an unbalanced force system with net force equal to 10 Newton towards the left hand side. So how do you solve this, guys? It's quite simple. So these are the options, by the way, 14, 12, 9 and 15. So let me just try to solve this question. It's quite simple for you guys. So first thing is, guys, This side you have like basically three forces acting. So these are all towards acting towards the right. So I'll take this positive. So you have 6 plus 5x plus 10 plus 15, which is all acting towards the right. So they should all be added. These are all all these three should be added. Because this is acting in the opposite direction, this should be negative. So it'll be what? Minus of 7x plus 13. And because the net force is also acting in the opposite direction, it will be minus 10, not plus 10, it will be minus 10 because it's acting towards the left. So it'll be minus 10. Now simplify this, find out the value for x. So you have 6 plus, okay, that's 16 plus 15, so that's 31. 31 plus 5x minus 7x minus 13x is equal to minus 10x, sorry, minus 10. So that's minus 2x plus 18 is equal to minus 10. So I'll take minus 2 to the other side just to keep it positive. So I'll take this to the other side. So it'll be 10 plus 18 is equal to 2x. So that's 28 is equal to 2x. So x is equal to 28 by 2, which is nothing but 14. So the answer to this question is option number A, which is nothing but 14. That's it. Now, if you want to find out what is the total, what is the value, you can just substitute the value of x in both the unknown values on the left hand side as well as the right hand side, and you'll get what is the value of force, the magnitude of force. So you'll be able to find it. So if they are asking you to find out the magnitude of force, then substitute the value of x in that particular equation. So 7 into 14 plus 13 would be what you get on the left hand side. On the left hand side, right hand side, and on the left hand side you can put 5 into 14 plus 10. Right? So that is nice. Moving on to the next topic is nothing but Newton's first law of motion, which is also known as inertia. So what does Newton's first law of motion state? Let's understand with a very simple example. Imagine there's a ball, guys. Imagine there's a ball, right? And this ball is basically rolling on a frictionless float. Alright, there's no friction whatsoever. Because there is no external force acting on it, because there is no force acting on it whatsoever, and the frictional force is also zero, what would happen? This ball will continue to move with that same speed, that constant speed, it will continue to move. This is what is known as your first law of motion. That is, an object will continue or will remain in the state of rest or in uniform motion in a straight line unless and until an external unbalanced force is acting on it. That's all. That is what it is. So what's happening? What's happening is that, okay, let's take the example of the box also. So two people are pulling it. Both of them are applying the same amount of force in the opposite direction, same magnitude of force in the opposite direction. What happens? The box will continue to stay remain in the same position. So what's happening is that because there is no external force, because the net force acting on the body is zero, it will continue to be in that state of rest itself. And that is what is said in Newton's first law of motion. A body will continue to remain in the state of rest or in the state of uniform motion in a straight line unless and until an external force is applied on it. Talking about mass and inertia, guys. So what is inertia? Is nothing but the tendency of a body or the property of a body to remain or to maintain that state of rest or the state of uniform motion. That the property is what is known as inertia. The tendency is what is known as first law of motion. So the property itself is known as inertia. So the thing is this, guys. The greater the mass, more is the inertia. So it will be, for example, imagine there's a table which is far more heavier. You would have to apply greater force, right? You have to apply a greater force. On the other hand, if the mass is lesser, if the mass is way more lesser, the force that you have to apply on it would be far more lesser. So in other words, the heavier object would resist more change, basically resist that change in motion greater compared to a table which is much more lighter, where the resistance is far more lesser. So greater the mass, greater the inertia as well. More the mass, more the inertia. Here is another question, guys. The inertia of an object tends to cause the object to increase its speed, to decrease its speed, to resist the change in state of motion, or to decelerate due to friction. What do you think is the right answer, guys? It's a very simple question. When you talk about inertia, inertia tends to cause the object to resist the change in the state of motion or rest. That is what inertia does. So greater the mass, greater the resistance, lesser the mass, lesser would be the resistance or lesser would be the inertia as well, right? Next concept is moment. What is moment? I know. Yes, what is moment? Think about it for a second. So guys, momentum, if you have to define it as nothing but the quantity of motion is what is known as momentum. So when a body is moving, it possesses some sort of momentum, which is basically represented by the letter P. And the formula is m into v, where m is the mass and v is the velocity. So we know that force applied on a body, or force that is required for a body to change its state of motion, is directly proportional to the mass and also directly proportional to the velocity. So greater the mass, more is the force that you have to apply. Greater the if you want more velocity, if you want to achieve more velocity, you have to apply greater force. That's what it means. So greater the mass, greater the velocity, more will be the forces. It's directly proportional. So I can say that F is directly proportional to m, which is nothing but mass, and F is also directly proportional to v, which is nothing but velocity. Now there is a quantity that shows the relationship between mass and velocity. There is a quantity that shows the relation between both mass and velocity, a quantity that relates both of them, and that quantity is what is called as momentum, which is represented by the letter capital P, and the formula is m into v, where m is the mass and v is nothing but the velocity. So the unit is basically simple, guys. The unit is basically kg meter per second. That is because SI unit of mass is kg, SI unit of velocity is meter per second, so kg meter per second is the unit. Let's say there's a car which weighs about 15 kg. All right. Now, if the velocity of the body is 0, then momentum is also 0, because 15 into 0 is 0, so momentum is 0. Let's say the car is moving at 10 meter per second. Then the momentum would be what? 115 into 10, which is 150 meter per second, which means that it has greater momentum. Let's say the velocity of the body is 20 meter per second. So what will be the momentum then? 20 into 15, which is far more greater than 150. So it's very clear that greater the velocity, greater would be the momentum as well. It's directly proportional. If the velocity is more, momentum is also more. And in all the three cases, the mass is same, so we do not worry about the mass. But because the velocity is changing, the momentum is also changing. So momentum is nothing but the product of mass and velocity, denoted by the letter P. P is equal to m into v. SI unit of momentum is kg meter per second, and momentum is a vector quantity because it's the direction of the velocity. Because velocity is a vector quantity, so momentum is also a vector quantity. So whichever is the direction of the velocity, momentum would also be in the same exact direction. Right? Moving on, guys, let's solve another question. Here's the question. A cricket ball of mass 0.20 kg is moving with a velocity of 1.2 meter per second. Find the impulse of the ball and average force applied by the player if he is able to stop the ball in 0.10 second. Your options are I, which is impulse, is equal to 0.5 kg meter per second. F is equal to 5 Newton, I is equal to 0.25 kg meter per second, and F is equal to 1.5 Newton, I is equal to 0.12 kg meter per second, and F is equal to 1.2 Newton, or I is equal to 2 kg meter per second, and F is equal to 5 Newton. First of all, guys, what is impulse? Impulse is nothing but the change in momentum, which is basically represented by either J, or you can also write it as IMP, which stands for impulse. Here they've represented as I. So let's take it as I itself. So I is equal to what? Change in momentum. So change in momentum. What is momentum? It is nothing but mass into, because mass of the body does not change, we'll say that velocity is changing. So change in momentum is what is called as impulse. Now, here's the thing, guys. They're asking you to find out what is the force and also impulse as well. So let's calculate the impulse first. So what is the impulse? Impulse is equal to what? Change. So mass is 0.20, and what is the velocity? Velocity is 1.2. So what is the impulse? So 0.20 into 1.2, you'll get as 0.12 kg meter per second. So 0.20 into 1.2 is 0.12 kg meter per second. That's out of the way. Now, another formula to calculate force is equal to impulse. Impulse is equal to, sorry guys, the formula is, okay, sorry. Yeah, I should have erased this. So impulse is equal to force into time. Impulse is also equal to force into time. All right. So put down the values. You have to calculate the force right now. So this is one way to do it. Or what you can do is you can use F is equal to m into a wala formula. Find out the acceleration. How do you find out the acceleration? V minus u by t. Final velocity is 0 because the ball is stopping. Initial velocity is 1.2. So you can calculate this way and then find out the value of force and then use impulse wala formula to calculate it. Or you can directly do it this way. So you know that impulse is 0.12. Force is what you're supposed to find out. Time is 0.10 seconds. So yes, so what is force? Force is equal to 0.12 divided by 0.110, which if you divide this, you'll get the answer as 1.2 Newton. So that is the answer. Simple. That's all. But yeah, calculation might take a little longer. Now, either you can go this method, you can do this way, you find out the impulse first, then use the formula force into time is equal to nothing but impulse, and find out the answer. Or you can find out the force first, and then directly use this formula, impulse is equal to force into time, and find out the impulse. So either way, if you want to find out the force first and then the impulse, that's also fine. Or you can find out the impulse first and then find out the force. Whichever way is comfortable for you guys, you can do it like that. Alright, so that's it. Let's go on to understand Newton's second law of motion. Newton's second law of motion is quite simple. The force applied on a body is a product of mass times its acceleration. Now, how do you calculate it? How did we come to that conclusion? So we know this, guys, that force is nothing but, so if there's the change in momentum that happens is directly proportional to the force, because if the momentum has to change, then you have to apply an external force. There should be an external force. So change in momentum, which is nothing but P2, which is the final momentum, minus the initial momentum, is directly proportional to the force. We also know that force is indirectly proportional to the time as well, time taken. Greater the time, lesser the force, lesser the time, greater would be the force, right? So this is also one more thing that we know. Sorry, the force is inversely proportional to, or indirectly proportional to, time taken for the change in momentum. So F is equal to F is indirectly proportional to 1 by T. Now we know that what force is directly proportional to P2 minus P1 divided by T. Now what is P2 and P1? P2 is nothing but M2 U1 or M2 V1. We'll take it as M2 V1. And P1 is what? P1 is equal to M1 V1. So we already know this. So we're going to substitute that over here. So we MV2 minus MV1 divided by T. So what did I take it as? Okay, yeah, the mass of the body is same. Sorry guys. So mass of the body is same. So yeah, let's take it as M. Okay, so M1 is equal, so basically M1 is equal to M2, which is nothing but M. So that's what they've done over here. And V1, this is V1, this will be V2. Alright, so this is V1, this will be V2. So yeah, substitute that values over here. So we'll get it as what? MV2 minus MV1 divided by T. Now what is, so M is common because the mass is same. So we'll take out mass outside. So we'll get V2 minus V1 divided by T. Now what is V2 by V1 divided by T? That is nothing but acceleration, because what is the formula of acceleration? V minus U by T is the formula. So V2 is the final velocity, V1 is the initial velocity divided by time taken. So that is acceleration. So what are you going to get? F is directly proportional to M into A. Now to remove the proportionality sign, we'll introduce a constant called as K. So what will you get? F is equal to Km into A. Now the value of K, when the units are in SI units, the value of K is equal to 1. So if you're taking SI units, then that is SI unit of mass and SI unit of acceleration, K is equal to 1. So what do you get? F is equal to 1 into M into A, which is nothing but F is equal to M into A. This is how you get the formula, that is F is equal to M into A. And this is your second law of motion, guys. So if you apply greater force, the acceleration will also be greater, because it's directly proportional. F is equal to M times A. So greater the acceleration, greater the force as well. And lesser the acceleration, lesser would be the force, right? So this is the second law of motion. Newton's second law of motion says that the measure of force acting on a body is a product of its mass times acceleration. And the force applied on an object is what is called as the rate, is basically equal to the rate of change of momentum, because we know that F is directly proportional to what? P2 minus P1. So because of this, we can say that, F is directly proportional to P2 minus P1. Because of this, we can say that it is equal to the rate of change of momentum. That's all. Alright. So that is the second law of motion, people. That is it. Done. Moving on to the question. Let's solve another question. A sedan car of 200 kg is moving with a certain velocity. It is brought to rest by an application of brakes within a distance of 20 meters. When the average resistance of being offered to it is 500 Newton, what was the velocity of the motor car? Alright, so mass is given. Okay, let's try to do this. Your options are 5 meters per second, 15 meters per second, 10 meters per second, or 20 meters per second. Let's try to solve this. Alright, so let's write on the given data first. Mass is given as 200 kg. Alright, so final velocity is equal to 0 because the body is come to a state of rest. So what will be the initial velocity? That is what you're supposed to find out first. Initial velocity is what you're supposed to find out. Distance is given as 20 meter and the force is equal to 500 minus 500 Newton. Why minus 500? Because that is a resistive force. In other words, the frictional force acting on it. So it's minus 500 Newton. What is the velocity of the motor car? First of all, guys, find out, okay, what shall we do? Okay, find out the acceleration first. Okay, so find out the acceleration, because we know. Okay, we'll find out the acceleration. So F is equal to mass into acceleration. Force is minus 500, mass is 200 into acceleration. So what is acceleration? 500 divided by 200. So that's what? 0, 0, 0, 0, 2 2s are 4, 2.5. So it is what? Minus 2.5 meter per second square. Now, which equation of motion should you use in order to get u? There is no time taken given. So I cannot use v is equal to u plus at. I cannot use this because there is no time given. I cannot use the second equation of motion also, s is equal to ut plus half at square, again for the same reason that I don't have time taken. So which formula can I use? Third equation of motion, v square is equal to u square plus 2as. So v square is 0 because the final velocity is 0. Initial velocity is, how much is it? Is, okay, what are you supposed to find? Yeah, 2 into acceleration is minus 2.5 into this 0. So this 2 into minus 2.5 into 20 is 100. So u square is equal to, u square minus 100 is what you're going to get. So u square is equal to 100. So u is equal to root of 100, which is equal to 10 meter per second. So that there is the answer to this question. People, u is equal to 10 meter per second. That's all. Simple. But yes, guys, you have to remember the 3 equations of motion. Never forget those 3 equations of motion. That is going to haunt you till the end of your life. So please make sure that you remember all of that. V is equal to u plus 80, s is equal to ut plus half at square, u square is equal to u square, v square is equal to u square plus 2as. All these 3 formulas, remember it till the end, because trust me, guys, they're not going to leave you at all. So make sure that you remember all these 3 equations of motion. And yes, guys, if you want to gain 100% knowledge of every single topics of this kind, and also solve some amazing questions just like this one, and improve your knowledge of every single topics like this, study in detail with the best of the best faculty there is in India, click on the link and enroll into the Vedantu Pro subscription course right away. Let me tell you what are the advantages. First of all, guys, you have unlimited live session. There is no limit to how many live sessions you can take. So you have ultimate value for money. There is no limit. You can attend only 20 sessions or 30 sessions, nothing like that. Unlimited live sessions, and all of those sessions will be fun-filled. I can guarantee you this much, because you will have amazing questions. You can interact with the teachers. You can interact with your friends. So it is going to be a fun-filled session, a lot of information, and more importantly, a lot of quizzes, which will not only help you to understand the concept better, but also help you to gain knowledge of that particular topics. And because of these quizzes, you have a unique opportunity to see how good you are among your peers. You can compete yourself with the rest of the world and see how good you have, you are in that topics. What are the weaknesses? Everything you'll be able to understand from those quizzes, from the topics that you're gonna, from the quizzes are taken up from those kind of topics where you have, you have to actually think a lot and get the right answer. So it will definitely push you to, understand the concept better, and also to push yourself to be better every single day. With all of these, guys, all of the sessions are already recorded. So in the sense, every single live sessions are recorded, and those sessions are also such a way that the recorded sessions also such a way that you can actually take the quizzes even while watching the replay, and still check out the leaderboards while watching the replay as well. Like, how cool is that? Even while watching the replay will be basically talking to you. You can take the quizzes and check out the leaderboards and see what are your weaknesses and how much improvement you have seen on an everyday basis. And yes, guys, this goes without saying, you can download all the premium content, every single handwritten notes, every single thing that is needed for you to succeed in your exams here and in the future. Everything would be available to you right here, right now. And yes, guys, this is probably the thing that is going to blow you out of the water, and that is this, guys. Every single session will not just have one teacher. With the master teacher, you will also have the class teacher to help you clear every single doubt of yours. It does not matter how many doubts you have, 100, 200, because I know for a fact that right now, because you're preparing for your exams, you would have a lot of doubts, but those, there are a lot of websites out there, but it takes a little longer for them to answer. Here, you get real-time answers right there and then with the help of the class teachers. And yes, guys, for all the practice questions that you guys are looking for, all the practice sessions, all the practice past year question papers, don't have to go anywhere for that as well. We have some amazing tests and assignments waiting for you guys, which will definitely push your envelope and help you to be better every single day. And these tests and assignments are designed such a way that the questions are taken from the best of the best sources, which will definitely push you to understand the concept much more better. It'll help you to think logically rather than just by hearting it and putting it down in a piece of paper, right guys? Because you have to study for knowledge, not for marks. And yes guys, if you have a lot of time in your hands, you can also attend 5,000 plus micro courses and crash courses, all for free. Now you must be wondering, sir, how do I enroll to the course? Very simple, people. I'm going to take a minute and show it to you guys how to actually do it. So first thing guys, go to the Vedantu website. So you can see this. There's already a session running. So click on any of the sessions. It does not matter. So let's say that what you have to do is basically click on subscribe to Vedantu Pro right now. Click on this link and enroll into the course. So if you're someone who's going from 9th standard to 10th standard, so click on 10th standard and go to CBSE 22. All right, that is for the next year. So once you click on CBSE 22 guys, you can either go for the 1-month subscription or you can take the year-round subscription until March 2022. So if you go for the 1-month subscription guys, the base price of that is 3,500 rupees. But don't worry guys, I have a surprise for you guys. Just wait till the end. You can also check out all the teachers that will be teaching you, all the results that we have achieved. Abhishek sir, Priyam sir, Amrit sir. These are also amazing teachers who will be teaching you guys. And you can check out all the results that has happened in the last year. So you can check that out as well. So what you will do is basically go to that and enroll into the courses guys. So if you once you enroll in the courses, you can actually check out all the replays of every single session and also check out the notes. You can download the notes and even check out whatever course you guys are eligible for as well. So basically guys, if you enroll into the courses, like I told you, the base price that is 3,500 rupees. If you use the coupon code AMEPRO, if you use this coupon code AMEPRO, you get a flat 20% discount. What is that? Flat 20% discount on that course price. So from 2,000 rupees, if you go for the revision course, that is, so revision course is going to be going on till March 21st. So from 2,000 rupees, if you use the coupon code AMEPRO, you get a flat discount of 20%, and the price drops down to 1,600 rupees. And if you go for the 1-month subscription course for the next year, that is for 2022 for your 10th standard, from 3,500 rupees, again a flat 20% discount. So the price will drop down to around 3,000 or 3,800 rupees. 2,800 rupees, something around that is what you're going to get. And if you think about the value for money, guys, what you're getting in that 1-month duration, you would have attended at least 200 sessions. That means that per session, you're just paying about 8 rupees. And if you go for the year-long course, it'll be far more lesser, which will cost around maybe about 6 rupees or 5 rupees per session. The link is given in the description. Enroll right now to avail the discounts and more importantly to study with the best of the best teachers and enjoy as well as gain 100% knowledge in every single topic. So like I just showed you guys, that is how you to enroll to the courses. The link will be given in the description as well in the pinned comment section. You can check it out, right? So that's it, people. Let's get back into the topic. Let's get into the third law of motion, which is probably the most easiest thing. This is something that you've probably heard from first or maybe second standard. So you do Newton's third law of motion. For every action, there's equal and opposite reaction. So this is what this is how I understood when I was a kid. So if you like when I was a kid, I think I was in 3rd standard or 4th standard. So someone explained, one of my senior explained me this way. So if you slap someone, you're definitely going to get a slap back. So for every action that you do, there's an equal and opposite reaction, which is in the opposite direction, but at the same magnitude as well. So that's how you understand Newton's third law of motion. Yes, people. So yeah, there's a lot of examples that you can give for this. For example, when you're walking, you exert a force so when you move your leg, you're exerting a force in the backward direction. So the soil that you're standing on or the ground that you're standing on will exert a force in the opposite direction, which is equal in magnitude but opposite direction, which is what propels you forward. So that is one more example of it. While swimming also, your action force is, you're trying to pull the water backwards. You're applying a force in order to push the water backwards. In return, the water will apply a force, a reaction force towards the front, which will propel you forward. Lots and lots of examples. Even for rockets, the fuel exhaust comes out in the opposite, in the downward direction, and the gases and all the other particles that are there will exert another force, which is opposite direction but equal in magnitude, which is what propels the rocket forward as well. So when an object exerts an action force on another object, the second object simultaneously immediately exerts another force which is equal in magnitude but opposite in direction. That is what is called as the reaction force, and that is what is your third law of motion. So those two forces are equal in magnitude but opposite in direction. In other words, for every action, there's an equal and opposite reaction. That's all. So that is it, people. With that said, let's do another question, and then we also have one more small topic, that is momentum. So we'll come back to that as well. So here's the question: is according to the third law of motion, action and reaction always acts on the same body, always acts on different bodies in opposite direction, have some magnitude, same magnitude and direction, act on either bodies at normal to each other. According to the third law of motion, action and reaction always acts on different bodies in opposite direction. Think about it, guys. Like for example, let's say that you throw a ball onto a wall. The ball will bounce back. So the ball is one object which exerts a force on the wall. The wall in return will exert a force on the ball. So there are two different objects which are in contact with each other. There's one action force, there's one reaction force, which are opposite in direction but same equal in magnitude, and that is what causes the ball to come back to you. Another example, like while you're walking, your leg is one object and the soil or the ground is one object. You exert a force, an action force on the ground. There's a reaction force that is acting on your leg, which is acted upon by the ground. So that is again action and reaction. So that is the answer, guys. This is another answer for that question. With that said, we are here towards the end finally. Yes, conservation of momentum. Let's do it. Conservation. What is conservation of momentum? See, guys, conservation of momentum states that the momentum of a body before collision is equal to the momentum of a body after collision. What do I mean by that? Imagine there are two balls, guys. Two balls of mass M and M. Alright, so MA and MB are the two masses of the body. So A is one ball, B is one ball. So MA is the mass of one ball, MB is the mass of the second ball. UA is the initial velocity of the first ball, UB is the initial velocity of the second ball. So what are you going to get? MAUA, which is momentum is equal to mass times velocity. So mass is MA and velocity is UA. So for the first one, the momentum before collision is MAUA. Momentum of the second ball before collision again is MBUB. After collision, let's say that because once they collide, mass is not going to change, but the velocity would, right? So what happens? The velocity is changed now to VA and VB, right? So velocity is VA and VB. That is the final velocity of the first body and the final velocity of the second body. So VA and VB are the velocities now. So once again, what would be the momentum, right? So this will be what? Where's my pen? Yeah, it's right here. All right. So let me just use a different color, guys, so that you can see much more clearly. So what will be the final momentum? The final momentum of body A will be MAVA, because that is the final velocity of the first body, and the final velocity of B would be MBVB, right? So VB is what you're gonna get. Now, according to the law of conservation of momentum, the momentum of a body before collision will be equal to the momentum of a body after collision. So what do you get? Total momentum before collision is MAUA plus MBUB, that is the momentum of both the bodies together, and momentum after collision is MAVA plus MBVB, right? So according to third law of motion, what is it? What do you say? That if there's a force exerted by one body on another, there's an equal and opposite force acted on the other body, which is in the opposite direction. So let's say that the force exerted by the first body on the second body is FAB. The force exerted by the first body onto the second body, and the force that is exerted by the second body on the first body would be what? FBA, which is in the opposite direction. Now what is force? Force is mass times acceleration. So we'll just put it as FAB is equal to what? Mass of the first body is MA, and the initial and the final velocity is VA minus VB. So it's nothing but force is equal to mass times acceleration. So it's MA and AA, that is the acceleration of the first body. So how do you find the acceleration of the first body? It's nothing but acceleration, the initial final velocity minus the initial velocity of the first body divided by time taken. So this is what you're going to get. So MA into VA minus VUA divided by time taken. For the second body, FBA is equal to MB into VB minus UB divided by time taken. Again, mass times acceleration. Now here's the thing, guys. The force acting on the force exerted by the first body and the second body is equal in magnitude but opposite in direction. And because of that, so the second force will be minus FBA because it's in the opposite direction. And we know that force is also a vector quantity. So you can clearly see that FBA is in the opposite direction. So that will be minus FBA. Substitute the value. What is FAB? It's MAVA minus UA, and for the second one, minus MB UB minus UB divided by time taken. TT gets cancelled. Just multiply multiply MA and MB into the equation. Like open up the bracket. So MAVA minus MAUA is equal to minus MBVB plus MBUB. Rearrange the equation. So what do you get? So I'll just okay. This will be what? Where's my pen again? Where's my pen? I can't. Okay, yeah, got it. My pen is like playing hide and seek. All right. MAVA. Take this to the other side. Wait a second. Okay. I think I made some mistake. One second. Oh no, yeah. Take all the U terms to one side and take all the V terms on the other side. So MAVA, this is a minus, so take this to the other side, it will become plus MBVB, which is equal to, take this to the other side, this will go to the other side, so only add plus MAUA plus MBUB. That's it. So final momentum is equal to initial momentum. That's all, guys. That's all. This is your final equation as well. With that, so basically the total momentum before the collision and the total momentum after collision remains same until and unless there's no external force acting on it. This is your law of conservation of momentum. For nidal collision, there's been no external force acting on a system. That is what we say. That is what we assume. So this is the last question, guys. Let's solve it and let's call it a day. Here's the question: two objects, each of mass 1.5 kg, are moving in the same line but in opposite direction. The velocity of each object is 2.5 meter per second. Before the collision, during which they stick together, what will be the velocity of the combined object after collision? 2.5 meter per second, 0.1 meter per second, 5 meter per second, or 0 meter per second. So two objects of the same mass, right? Each of them have the same mass. So M1 is equal to 1.5 kg. M2 is also equal to 1.5 kg itself. All right. Now, both of them are going with same velocity as well, but then in opposite direction. So you can say that UA, which is the initial velocity, is equal to 2.5 meter per second. UB is equal to minus 2.5 meter per second. Why minus? Because it's in the opposite direction. So that's the one thing that do not get that wrong, guys. So that's that. Now, after collision, they both combine. And what will be the velocity of the combined object after collision? So what happens is, after collision, they both stick together. So that means that the final velocity of both the bodies will be same because they are sticking together. So final velocity, what is that? So V2 is equal to V1, which is equal to V. So it's K plus V. So according to the, again, momentum of the conservation moment, what is the formula? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So what is M1? 1.5 into U1 is what? Okay, we took it as UA. So that's 2.5 minus 1.5 into 2.5, which is equal to 1.5 into V plus 1.5 into V, because V1 and V2 is the same. So this is basically 0. 1.5 into 2.5 minus 1.5 into 2.5 will be 0, which is equal to what? 3V, right? Because 1.5 plus, so what will this be? This will be 1.5 plus 1.5 into V. So that's something with 3V. So what is V? V is equal to 0 by 3, which is nothing but 0. So velocity, the final velocity of the body is 0. That means the bodies after collision will come to a state of rest. That's all. So the answer to this question is 0. That's all, people. That's all for today then. So that's it, people. Thank you for joining. Do not forget to click on the link, check out the courses, because we have some amazing things for you guys in store. And yes, guys, once again, our intention is to make sure that we are providing the cheapest of cheapest price to every single corner of the world, and more importantly, provide quality education with quality teachers. That's our motto. That's what we believe, and that's what we're trying to achieve over here. So check out the link. Coupon code is AMPRO when the discounts. Check it out and do let me know what you think about it. So yeah, guys, once again, do not forget to like, share, and subscribe, because yes, we have some super awesome things coming for you guys. So make sure you like, share, and subscribe and be a part of the squad. Thank you for joining. Catch you guys soon. Take care of yourself. Stay safe. Until then, this is Anoop saying adieu for now. Take care.